Hi there, it's Dave Clayton here from DCSE Limited. I'm the Senior Software Engineer, and in this video we're going to talk about .NET Core Microservices behind the Fantasy F1 online portal. So this is part 4 of the series. Hopefully you've watched the other videos, so you should have a bit of a taste of how the project hangs together. So first of all, I'm going to just basically give a demo of how this all hangs together and how it works locally. So when developing locally, we have a Docker Compose file we can use to spin everything up. So if I use that, you'll see that is now starting up all the services. And what we can do is actually have a look there. So we've got RabbitMQ and all the various bits and pieces spun up there. So here we have RabbitMQ up and running, and if I was to look at the front-end website, you'll see it's very basic at the moment, but we could set up a new user and once we do that, so we get a registration. So behind the scenes what this has done now is actually gone off to the user service, persisted that record into the database, and then used the message queue to notify the email service to send an email out with a activation link. So if we look at the database, we should be able to see, here we go, so user is registered in there successfully, and if we check the email component, so locally we use an SMTP server, so a fake one which is running in a Docker container. So what that allows us to do is actually trap that email, so it just means we're not actually sending anything. And then you can see it's actually sent that out with an activation link. So click on that and that will take us back. We've now been confirmed, and I should be able to log in. Perfect, so we're now logged into the site, and if we go to my account, we can see here, we can choose an avatar. Well, anyway, we don't need to do that. So name, email, avatar, and password changes, kind of all the functionality we have for now. So nice and simple. So what we'll do is we'll have a look at how we actually structure some of this stuff. So what I'm actually going to do is I'm going to stop the user service component. So if we look at the dashboard for Docker, and we see what's running, I'm just going to close down this user service, and then we can run that up in Rider. So we should be able to just run that with no problems. Yeah, all listening and running on Swagger. So probably a good place to start then. So this service only has a couple of endpoints on it. So there's an account endpoint which really allows register, confirm email, all the bits and pieces around a user actually creating their account. And then for registered users, we have a simple endpoint just for getting the user details and actually updating them. So nice and simple. And what we will do is we'll have a look through the back end here. So what I'm going to do is I'm going to start from the startup file. So pretty standard .NET Core stuff. We're running .NET Core 3.1 at the moment, but there are plans to up that to 3.2 now that's been released. So yeah, when we start up, we are using an app settings JSON file. We don't have different files per environment. We don't really need to do that with the way we're using Kubernetes. So most of that stuff's stored in a config map and also pulled down from Azure Key Vault at the point of deploy. But the stuff we do have in the config map, we are loading out into the configuration models. And then we're just really going through configuring authentication. So that's handling all the JWT, so refresh tokens, all that sort of stuff. Yeah, so very standard stuff there. So yeah, configure the database, all the dependencies, and then we're registering up some custom components which are actually coming from NuGet. I'll talk through those slightly later. Setting up the RabbitMQ, added Swagger, And then we have some health checks here, which we use for Kubernetes purposes. So we need to know if the endpoint is actually healthy. So the two dependencies this service has are RabbitMQ and MySQL. So RabbitMQ health check is actually a custom written component, and the MySQL is out of the box. You just give it the connection string and it checks that it's there. So we can do a nice example of that. If I was to stop the MySQL instance running in Docker, oops, and then we try and start up the service, what we'll see is that health check will kick in. So you should see it will start trying to connect. There you go. And it just uses a thing called poly, so it just checks every so many seconds, so we do that exponentially. So if I then start up that MySQL instance again, you'll see this will suddenly connect and spring into life. And this is really useful for Kubernetes, so you liveness and readiness probes all works together nicely. Go away. So that's kind of at the startup. So then if we look top down from the controllers, so we like to keep our controllers nice and slim. So if we look at the account controller, we'll use register as an example. So obviously it's a root and we have it's a post method, and then all we really have in here is the Swagger metadata, and then the method itself obviously takes a request object and returns an action result, and it just uses a controller service with the register method. So what we've done is abstracted the logic out of the controller. It just makes more sense for testing purposes. So you don't really want to unit test your controllers, so this enables you to not worry about that so much. So if we drill down into that account controller service and we look at the same register method, you'll see this is just basically where all the logic and the business logic for how it would actually perform an operation. Again, most of the code in here is pretty simple, it's just mapping the responses back. So we actually have a security service which performs the register in this case, and then we just return the relevance results based on the actual output of that method. So if we look down a bit further into the security service, you'll see if we find the register method, which is here, so doing some checking, returning invalid parameters already exists, and then we set up the actual new user and try and create that using the user manager, which comes with identity framework. So all the user management is done via identity framework. And that's a combination of that with entity framework core, and then obviously we return back depending on what the result was, so that's abstracted away nicely. In terms of data access, we're actually using entity framework core like I mentioned, and we have our repo. So this is the user service, it only has a user repository which is very small, so we're just doing some standard link just to actually get that stuff and save it and persist it. So nothing particularly clever in here, as it's quite a small service. And obviously DB context, that sort of stuff. So that's kind of it end to end. So what we'll do now is we'll have a look at our testing strategy. Testing obviously is really valuable, really important. So what we like to do is actually write unit tests around pretty much everything. So we do have some controller specs just to check that certain things are marked as post, just sort of verification tests really. And then things like the security service that we saw would have a load of tests around the register method, for example. We're actually using our own custom framework here. So basically given when then syntax, so nice BDD style of writing tests, which makes it nice and clear. We've actually written a blog post about this framework that we wrote. You're free to have a look at that and pillage it and use it if you want. You're more than welcome to do that. So basically just we feel it gives us a nice syntax around our tests. So this test, for example, is checking for an empty email address. So we can say, given an instance of the service and I do not pass an email address, when I make a call to register, I should receive an invalid parameters response. So it's just quite clear what that test is doing. And the nice thing is it's just bog standard C# code, so we get IntelliSense, you navigate through the code, all that sort of stuff. So I won't dwell on that too much. Like I said, if you're interested in this, either give us a shout or read the blog post. So that's unit tests. And then one of the really powerful features of .NET Core is Microsoft give us a utility called Test Server. What this allows us to do is actually start up a copy of our API in memory. So we can actually spin it up and hit it via a HTTP endpoint. And you point it at your startup class, so you guarantee you're actually running your service as if it would be running in the wild. Now, just a caveat to that, I've got a test startup file here. What I'm actually doing is implementing from the startup file, and I just wanted the ability to perhaps override some of the DI mappings, so in this case RabbitMQ. So I don't actually want to test that RabbitMQ is there and working. I don't need to test that because it's kind of out of scope of this component. So what I do is I just mock up a sender, and then what that allows me to do is when the email message, for example, goes onto the queue, this just writes it to a file, and then I can just read it back out and get the activation code to do a full circular end-to-end test. So then the test server can then start up based on that startup. And then in this case, I'm actually using a physical database. What you could do, if you're running on Windows, I'm currently running on a Mac, Windows allows you to have in-memory databases running from your entity framework migrations. So what that means, you can have an in-memory endpoint and an in-memory database, which is spun up brand new every time you run the test. It's super quick, and then you can do full integration testing, so you can hit your endpoint and verify things end up in the database. So you can fully test that component end-to-end, all in memory. I'll show you an example of how these tests run in a minute, but I'm not using the in-memory database, just to caveat that. So with the test base set up, what we can do then is, so I've got some just database integration tests in here. Again, we're not doing a lot with the database, so this is just integration testing that, so name has a, I think it's 128 character limit or something, so if I basically, given that I call that with a correctly defined name and I try and save the user, it should be saved. If I pass through a name that's got 129 characters, for example, it shouldn't save, I should get an error. So that's just integration testing back off of that. And then endpoint testing, this is the sort of more exciting stuff. So if we look at the account endpoint tests, so for register, for example, so again, using the same framework, so register should create a new user. So what we can do is say, given I've got a valid name and a valid email address and a valid password, and I construct a call to, I've got a valid register request. When I make a call to register, so that's actually going to hit the HTTP endpoint, it should receive a 200 response back, and the user should be created in the database. So this is actually going to go off and use Entity Framework to check that that email, that user is in that database. So like I said, full end-to-end, really powerful stuff. So I'll show you what that looks like when it's running. So like I said, this is really, really quick. So I've got 136 tests in this project. We'll just kick them off. 99 of them are unit tests, so you'd expect those to be blistery quick, which they are. And then the integration test, you'll see there's an initial pause while it runs. I know there's a failure. It's because I just entered some stuff into the database, so that's expected. But yeah, so 37 tests, and you'll see there's an initial pause where it spins up, and then they run really quickly. So what I'll do is I'll just run those again because they should pass this time. It's because I gave you a local demo. It's just there's a user stuck in the database, and it's not expecting it to be there. As you can see, these just run very, very quickly. So I think, was it 3.1 seconds there? 4.3 overall. Yeah, really quick. No need for all the GUI tests and that level of testing at this point. Proper obeying the test pyramid. So that is really where I'd like to wrap up on that. So yeah, we're doing the usual, solid principles, clean coding, all the usual architectural patterns, trying to follow those where possible, and test pyramid testing, all that good stuff. I hope you've enjoyed this video. If you've got any questions or comments, please feel free to drop me a line. I'll see you next time.